Hello, in this video, I will explain to you on how to solve this problem. So the question is, a block is projected up a frictionless inclined plane with initial speed VO is 3.50 meter per second. The angle of the incline is theta is equal to 32 degrees. How far up the plane does the block go? How long does it take to get there? And what is its speed when it gets back to the bottom? Okay. Let's see here and draw all the forces that works in this block here. Remember that this one here is theta, right? The angle here is theta, and that theta is 32 degrees. Good. Now let's draw the forces that work on this block here. The most obvious one is the weight by the block here. Let's name this as Fw. But then Fw is the mass times gravity of the block, right? However, I want to use this one here, the one that is parallel to the plane as the x-axis, and the one that is perpendicular to the plane as y-axis here. So I will use this coordinate. So we need to project this Fw into x and y axis, right? So here we also have this theta here, right? So we can project this into y-axis. And we will have this one here as Fw, but on the y-axis. However, we can use trigonometry to calculate this here. This is the adjacent side and this is the hypotenuse. Adjacent and hypotenuse is cosine. So I'll have Fw cosine of theta. Okay, we can also play the same game here for this one here. So we will have this one here that will be Fw but on the x direction. Because this is cosine, obviously this one will be sine, right? So I will have Fw sine of theta. And that is the force that working here. Good. And then we need to calculate the acceleration. Okay. Oh yeah, one more forces that works on this is the plane also giving force to the block. And I will name that force here as Fn. However, because this is frictionless, we don't need to care about Fn here, right? So we only care about the x direction here. So we will have at x direction. At x direction, I will use the Newton's second law. So we will have sigma f is equal to mass times acceleration. However, this is on the x direction, so I will have x here and the acceleration also x here. Good. And the only force that work on the x-axis here is this one here, which is Fwx. However, that is on the negative direction, right? Because x positive is there. This one will be negative side. So we'll have minus, and then we will have Fw sine of theta. And that will equal to the mass times the acceleration in the x-axis. But the weight here is mass times gravity, so I have minus mg sine of theta, and that will equal to the mass times acceleration in the x-axis. We can divide both sides by m, so we will have this one here, so we can get the ax here. So ax is equal to minus g sine of theta, and we can just plug in the numbers. So we'll have ax is equal to minus 9.8 multiplied by sine of 32 degrees, and nothing that we can do except plug that into calculator. Let's do that. So we'll have minus 9.8 multiplied by sine of 32, and that will equal to minus 5.19. So I have minus 5.19 meter over squared seconds. However, that is not the one that is asked by the question. Okay, let's see what can we do next. Okay, we have the acceleration in the x direction. However, we also have the initial speed here. VO is equal to 3.50 meter per second. Okay, so we'll have VO here is equal to 3.50 meter per second. And if this is pushed, and eventually it will stop somewhere here, right? So we will have to answer that in question A. How far up the plane does the block go? So we can use the kinematics formula here, which is Vt squared is equal to Vo squared plus 2ax. Right? Because eventually the block will stop here, so we'll have our Vt is equal to 0 meter over second. Right? So we can have this here as 0. And then VO is 3.50. So I have 3.50. But that will be squared. And then plus 2. And then the acceleration is this one here. So I have minus 5.19. And then we will have x here as the unknown. And then let's move this to the left-hand side. And we can remove this negative sign. So we will have 2 multiplied by 5.19 of x, and that will equal to 3.50 squared. And we can just use this. X is equal to 3.50 squared divided by 2 multiplied by 5.19. So how far up the plane will go? Let's just plug this number into calculator. Good. So I have 3.50 and then squared divided by 2 multiplied by 5.19. 2 multiplied by that. Yeah, this one, like this. Right, so we will have 1.18 meters. So we'll have 1.18 meter. And that will be our answer for question A. Okay, let's highlight that. And then let's move on to question B. Okay, for question B, that is another kinematics question. So we will have Vt is equal to Vo plus At, right? So we need to find out what is T. Vt here is 0, so we will have 0. And then Vo here is 3.50. Okay, and then I will have plus, the acceleration is minus 5.19. And then multiplied by t. Move this to the left hand side, so I have 5.19t is equal to 3.50, and then that will equal to our t here, and that will be 3.50 divided by 5.19, and that t is equal to, okay, let's do that. So I have 3.50 divided by 5.19. Okay, and that will be 0.67 second. 0.67 second. Okay, let's highlight that and then move on to question C. Okay, for question C, what is its speed when it gets back to the bottom? Okay, so if we need to find out what is the speed when it gets to the bottom, we need to change this into the initial speed, and we need also to change this as the final speed that we don't know yet. So this we pretend that it is unknown. Okay, so for the question C here, we will have Vt is equal to Po plus At, right? And then our Po here is equal to 0, right? So we will have 0 here because this one start from stopping from here, and then the acceleration is the positive version of this one here. So we'll have Vt here is equal to 5.19 and then multiplied by this time here, which is 0.9067. Why? Because it will get the same time when it's going up and also going down. So the final time here, when it gets back to the bottom, that will be 5.19 multiplied by 0.67. And we will have 3.5, which is the same, right? It's 3.5 meter over second. Okay, and this number here comes because of the rounding error, and that is fine. And then we have this x, t, and pt, which is all the answer for this question. Hopefully I did not make any mistakes during my calculation. And as usual, thank you for watching. If you get questions, send me your problem to rdsatria11@gmail.com. Thank you for watching and see you in the next video. Bye bye.